Alright, so part 2 for Integrated Math 1. Our topic today will be graphing linear equations in standard form by, this is part 2 of the video, so we're going to be using x and y intercepts to graph linear equations in standard form. For our second method, we're going to be using x and y intercepts to graph linear equations. So let's review some vocabulary on what an x-intercept and a y-intercept is. An x-intercept is a point that crosses the x-axis. So that point is going to lie on the x-axis on the coordinate plane. And that's where the line is going to cross the point and the x-axis. The y-intercept is a point that crosses the y-axis. So the point y-intercept is going to be on the y-axis, and the line is going to cross the point and the y-axis. Now that we went over some vocabulary of x-intercept and y-intercept, let's find out, using these two coordinate planes, what are the x-intercepts and what are the y-intercepts. So let's take a look at this first coordinate plane on the left. We have the coordinate point -2, 0 and 3, 0. These 2 points lie on the x-axis, so they are x-intercepts. So -2, 0 and 3, 0 are x-intercepts. And notice that x-intercepts always have a y-coordinate or y value of 0. Here at -2, 0, the x-coordinate is -2 and the y-coordinate is 0. Here in this coordinate point, the x-coordinate is 3 and the y-coordinate is 0. So we can say that all x-intercepts always have a y value of 0, and this is going to help us out a lot when we find the x-intercepts algebraically. Next up, we have on our second coordinate points, we have the coordinate point 0, 1 and 0, -3. Notice that both of these coordinate points are on the y-axis. So 0, 1 and 0, -3 are y-intercepts. And notice that y-intercepts always have an x value of 0. Again, this is going to help us find the y-intercept algebraically because we know that the x value is 0. Alright, so if we have a linear equation in standard form, we can use the x and y-intercepts to graph the linear equation. There are going to be 4 steps to do so, and we're going to be doing it algebraically. So step 1, find the x-intercept. So to find the x-intercept, we're going to have to plug in 0 for y and then solve for x using algebra. Step 2, we want to find the y-intercept next. We want to plug in 0 for x, then solve for y. Step 3, we want to plot our x and y-intercept on a coordinate plane. And step 4, we're going to connect our x and y intercepts to form our line. Alright, so for example 1, we want to find the x and y intercepts and graph the linear equation of 3x minus 2y equals 12. This linear equation is in standard form, so we want to find the x-intercepts and y-intercepts. So in our first step, we want to find the x-intercept. Notice that all of our x-intercepts have a y value of 0. So what we're going to do is we're going to take the standard form equation 3x minus 2y equals 12, and we want to rewrite it, but we're going to plug in 0 in for y, and we're going to solve for x. Well, 2 times 0 cancels out, so we're going to cross it out. So we have 3x equals 12, get x by itself. 3 cancels, and we have x is equal to 12 divided by 3 is 4. Now, when I write this as a coordinate point, we said that all of our x-intercepts have a y value of 0. So when I write this as a coordinate point, my x-coordinate is going to be 4, and my y-coordinate is going to be 0, because all x-intercepts have a y-coordinate of 0. Next up, we want to find our y-intercept. So we're going to have the equation 3x minus 3y equals 12, but we're going to plug in 0 in for x. So it's going to be 3 times 0 minus 2y equals 12. And the reason why I'm doing this is because all y-intercepts have an x value of 0. 3 times 0 is 0, so that cancels out. and we're left over with negative 2y equals 12. We want to get the y value by itself, so we're going to divide each side by negative 2. That cancels out, and we get y is equal to negative 6. When I write this as a coordinate point, all y-intercepts have an x value of 0, so my x-coordinate is going to be 0, and my y-coordinate is going to be negative 6. Now that I have my y-intercept and my x-intercept, I'm going to go ahead and plot my y-intercept and my x-intercept on my coordinate plane. So my y-intercept of 0, negative 6, I'm starting at the origin at 0, and I'm going down 6 units. So down 6, 1, 2, 3, 4, 5, 6. My point is right here. That's my y-intercept of 0, negative 6. That's my y-intercept. It's my y-intercept because this coordinate point lies on the y-axis. Next, I'm going to plot my x-intercept. My x-intercept is going to be 4, 0. So I'm going 4 units to the right. 1, 2, 3, 4, and no units up or down. So my coordinate point is going to be right here. That's my x-intercept. I know it's my x-intercept because this point lies on the x-axis. So here's my x-axis, and here's my y-axis. So my coordinate points, my x-intercept 4, 0 is right here. That's going to be my x-intercept. Now that I have my x-intercept and my y-intercept, I'm just going to take my marker and just connect these two lines. And we're done. We have successfully graphed a linear equation in standard form using a y-intercept and an x-intercept. Alright, for example 2, we want to find the x and y-intercepts, and we want to graph the equation using the intercepts. I have my equation in standard form of 5x plus 3y equals 15. Now go ahead and pause the video and try to do this problem on your own, and then once you're done, unpause it and we'll work on it. Alright, let's first find the x-intercept. So the x-intercept, we know that the y value is 0. So we want to take the linear equation 5x plus 3y equals 15 and substitute that y for 0. So I have 5x plus 3 times 0 equals 15. 3 times 0 is 0, so it cancels out. So we have 5x equals 15. Divide each side by 5. The 5 cancels, and we get that x equals 15 divided by 5 is 3. So since my y value is 0 and my x value is 3, that means my x-intercept is going to be 3, 0. Next up, for my y-intercept, I know that my y-intercepts always have x values that are 0. So knowing that, I'm going to take my x value of 0 and I'm going to substitute it in for the equation in standard form. So I'm going to have 5 times 0 plus 3y equals 15. 5 times 0 cancels out, and we get 3y is equal to 15. Divide each side by 3, and I get that my y value is going to be 15 divided by 3 is 5. So when I write my y-intercept as a coordinate point, I know that my x value is going to be 0, and my y value is going to be 5. So my y-intercept is 0, 5, and my x-intercept is 3, 0. Alright, now that I have my y-intercept and my x-intercept, I'm going to go ahead and plot my y-intercept and my x-intercept on this coordinate plane. So let's graph my y-intercept first. I'm going 0 units to the left or right. I'm staying at the origin, and I'm going up 5 units. So I'm going 1, 2, 3, 4, 5 units up. So here is my y-intercept of 0, 5. And that's going to be my y-intercept. Here's my x-axis, and here's my y-axis. Next, I'm going to plot my x-intercept. My x-intercept tells me that I'm going 3 units to the right and 0 units up or down. So here I have plotted my x-intercept of 3, 0, 3, 0, and that is my x-intercept. Now that I have both my y-intercept and my x-intercept plotted on the coordinate plane, I'm going to go ahead and connect my line through the y-intercept and the x-intercept to create my line of 5x plus 3y equals 15.